What's up, class? Evans here. I want to go over how to calculate a series circuit and show you the math that you would need to do to put this out. In a series circuit, the current is the same as it flows through here, but the voltage drops a different rate at each one of the resistors. So we're looking at two different things: the voltage, the resistance, and the current as a total, and the voltage at individual pieces, because we already know the resistors at individual pieces, and we know that the current at each would be the same number. Whatever we get for total, it would equal what would be read here at these four resistors. So our first step is to mark what we do know, and that is that the total voltage is what's on the battery, which is 9 volts. So there's no math to worry about there. The next piece is to total up all the resistance. We have 20, 3.5, a 17.3, and a 1 kilo. That's 1,000. So we're going to take those and add those up. And we get 1040.8 ohms. To calculate the current, voltage equals resistance times current, so then we just divide. That would be 9 divided by the 1,000. And I get a current of 0.008647, and it just kind of goes on. I'm going to stop, and I'm going to keep that number in my calculator. This would be in amps. Now to calculate the voltage at 1, 2, 3, and 4, voltage is resistance times current. So the current is this value, and I want to keep, by the way, I want to keep all my math over here and just my answers on the side, so it makes it easy to grade later and get all the numbers later. So I'm going to take my current, I'm just going to call IT, and it's going to be multiplied by 20, and then by 3.5, by 17.5, and by 1,000. So like for instance, V3, I take the number that's already in my calculator and just put times 1,000. And I get that value, 8.647 amps. If I divide by 1,000, I get it back to the original number, and I can multiply it by another one, times 17.3. And then I could divide it by 17.3 and multiply it by, and just keep moving up the row. I'll let you finish off these last two, and then you need to try to do this one on your own. Now let's look at parallel. Make sure that you're showing all the math that's needed to complete these, else it won't count. All right. The difference with a parallel circuit is now the voltage is the same. The voltage of 25 volts consistently goes through each one of these resistors, and then it's the current that would be a different reading at each resistance. Our voltage total is what is at the battery. No math there. The resistor, that's the weird one. In a parallel circuit, a resistor is the total resistance is inverted equals the resistance at 1 inverted plus the resistance at 2 inverted plus the resistance at 3 inverted. So the total resistance is the inverse of the sum of the inverses. That just means 1 divided by. To do resistance in my calculator, there's an x-1 button. Mine is right up here. Yours in class is somewhere over here. And I'm going to write my math as 300 inverse plus 47 inverse plus 232 inverse. So 300 inverse plus 47 inverse plus 232 inverse equals, that's not my answer because I need to take the inverse of that. So I just press inverse. See how it says answer inverse? Enter. And that is my total resistance. To get the total current, that's voltage divided by resistance. That's 25 divided by the number I just calculated. I'm going to keep the number as a whole. I'm going to press the inverse to make it at the bottom and then multiply it by 25. That's just one trick to use. Now I have my current, 0.723, and that would be amps. To finish it off, to find the current, current is, again, voltage divided by resistance. So that would be 300 divided by that resistor. And then I2 would be the next resistor. And I3 the same. And then once you get your answers, just write them here. And I'll let you get the last two, and then complete the one next to it, making sure to show all of your math work. Turn this to me as soon as you can to get your grade. Thank you. Bye.